Hi and Assalamualaikum. My name is Amir Ashraf bin Azmil, number metric 1200522. Welcome to the world of mathematics, and we are in linear algebra country. Before we start, I want to say thank you to our king, which is Dr. Azrul, for leading and guide us. Today's topic is about eigenvalues and eigenvectors. We will go through the definitions, applications, and theory of these topics. So, let's start it. Okay, this is my poster about eigenvalues and eigenvectors. Today, we're gonna go through this topic based on this poster. Don't worry, you don't need to zoom in the poster because I already put the content inside my slide. What is eigenvalues and eigenvectors? Maybe we're not really familiar with this term, but this theory has helped us in many inventions. For sure, I will not share about the application for now. So, let's go for the definitions first. Eigenvalues and eigenvectors can be defined by letting A be an n times n metric. For some scalar, eigenvector lambda, a non-zero vector v in Rn such that AV equal to lambda v is an. For eigenvalue, A is a scalar lambda such that the equations AV equal to lambda v, it has a non-trivial solutions. For example, if AV equal to lambda v for VA equal to 0, we say that lambda is the eigenvalue for V and that V is an eigenvector for lambda. Enough for the definitions. Let's see the applications of eigenvalues and eigenvectors. There are so many things that use eigenvalues and eigenvectors. For example, communication systems, designing bridges, designing car stereo system, electrical engineering, even mechanical engineering. There's actually more than this that I can't list out. It's shocking, right? The terms are not really common in our life, and it is actually give us so much benefit. For today's presentations, we're going to talk about one of the application, which is communication system. Claude L. Wood Shannon, born in April 30, 1916 and died in February 34, 2001, was an American mathematician, electrical engineer, and cryptographer known as the father of information theory. Claude Shannon utilized eigenvalue to calculate the theoretical limit of how much information can be carried via a communication channel such as telephones, line, or the air. The eigenvalue and eigenvectors of the communications channel that are represented as a metric are calculated, and then the eigenvalues are water-filled. The eigenvalues are therefore essentially the gains of the channel's basic modes, which are recorded by the eigenvectors. Do you know how messages can be mixed up and misinterpreted? To explain this, on 1948, Claude Shannon and Warren Weaver, an electrical engineer, developed a model that known as the mother of all models, which is the Shannon and Weaver model of communication. The purpose of this model developed is to explain how messages can be mixed up and misinterpreted in the process between sending and receiving the message. The Shannon and Weaver model of communication is a mathematical theory that claims human communications can be broken down into 6 fundamental concepts, which is sender, encoder, channel, noise, decoder, and receiver. The Shannon-Weaver model starts with sender of information source. They are the person or object or things and information source who has the information to begin with. The information source starts the process by choosing the message to send, someone to send the message to, and a channel through which to send the message. The next step in Shannon-Weaver model is the encoder. The encoder is the machine or person that converts the idea into signals that can be sent from sender to the receiver. The Shannon model was designed originally to explain communication through means such as telephones and computers, which encode our words using codes like binary digits and radio waves. However, the encoder can also be a person turns an idea into spoken words. written words or sign language to communicate an idea to someone. The next step in Shannon-Weaver model is the channel. The channel of communication is the infrastructure that gets information from the sender and transmit through to the decoder and receiver. We sometimes also call this the medium. The next step in Shannon-Weaver model is noise. Noise interrupts a message while it is on the way from the sender to the receiver. It's named after the idea that noise could interrupt our understanding of a message. There are two types of noise, internal and external. The next step in Shannon-Weaver is, of course, a decoder. Decoding is the exact opposite of encoding. Shannon and Weaver made this model in reference to communications that happens through devices like telephones. Shannon and Weaver made this model in reference to communications that happen through devices like telephones. So in this model, there usually needs to be a device that decodes a message from binary digits or waves back into a format that can be understood by the receiver. The last step in the Shannon-Weaver model is receiver. This is the step where the person finally gets the message, or what's left of it after accounting for noise. Eigenvalues and eigenvector have been applied in channels where it used to know how much information can be transmitted. This is the use of eigenvalue and eigenvectors inside the models. To conclude for today's presentations, we must know that eigenvalues and eigenvectors are utilized for more than just calculating variables. Other challenges such as computer science and modern physics were also solved with this. We won't be able to achieve high-level technologies without it. I hope that we can discover more new designs and applications for eigenvalues and eigenvector. This will help us to invent more in the future. Oh yeah, before I forget, this is all my references for making this research succeed well. Without these references, I don't think I can finish my research and present it. That's all. Thank you and Assalamualaikum warahmatullahi wabarakatuh.